Should we talk about some cycloalkanes? Let's talk about some cycloalkanes. We talked about regular alkanes. Do you remember what regular alkanes look like? They're just straight chain alkane like this. Or you can have alkanes with a side chain like this, or maybe, well, I guess this would just make it longer. But we can do all kinds of stuff with alkanes. Here's an alkane. As long as everything is single bonded, you have alkanes. But here's what's interesting. Not always do you just get to make a new side chain. Sometimes you can make a cycloalkane like this. What if I do this? That's a cyclo. How do I know? Because it's in a cycle. I think you get it. So this would be what? 1, 2, 3, 4, 5. So this would be cyclopentane. Pent meaning 5, ane meaning all single bonded. Here's the difference. If I have a straight chain alkane like this, well, there's going to be 3 hydrogens on the end of each one like this, right? And that means that this is going to be like C4H10 because you multiply this by 2 and then add 2 because there's an extra hydrogen on the end when all the alkanes in the middle only have room to bond to 2 other hydrogens. So you're always going to get this formula. But with cyclos, that's not true. It's just times 2 because all of these are just going to have 2 hydrogens sticking off the end. So this would be a C5H10. Whereas if I just have regular pentane like this, that would be a C5H12. So why does this matter? Well, the first thing is they're great for naming practice because we haven't done a lot of naming practice yet here in organic. But the other is that they're going to have a completely different behavior. And that's the thing we want to look at as we're practicing this. So let's make like a cyclobutane. You might know it as a square, but it represents cyclobutane. Then in 3D, maybe it doesn't look like this. Maybe it has kind of this like taco shape. I'm going to try to give you that look. It could be like that. That's a cyclobutane. So what it really looks like in 3D, hard to say without more experience in chemistry. Let's look at cyclobutane here. I'll write it out just to give you the heads up. Cyclo means it's in a cycle. Bute means 4, and ane means all single bonded. Cyclobutane. Now, what's cyclobutane going to be if I put a side chain on it like this? Well, the first thing that we have to do to name this correctly is to number all of the carbons. And you always put the lowest number where you're going to start your carbon chain name so that whatever you end up with, you're going to have the lowest possible number for your naming convention. I'll give you an example here. This is a 1-methyl cyclobutane. Okay, and what if I make this a ethyl and I make this a methyl? Well, then this would be something a little bit different. I want to make it just a little bit bigger here. Sorry if I disrupted you. Let's renumber this. 1, 2, 3, 4. Which carbon do I want as number 1? I had labeled it here, but is that right? Well, this is an ethyl group here. And this is a methyl group here. 1 carbon. This carbon. We don't count the 1 in the cyclo part. Cyclobutane takes up these 4 carbons. So this is a methyl group on this end, and these 2 comprise a ethyl group here. In fact, let's put another one out this way. Let's do a propyl group. It's like propane, except it's not because it's missing a hydrogen. And it's bonded, right? So it's not propane because it's missing a hydrogen. It's a propyl. This is a methyl, and this is an ethyl. And of course, the reason it's missing that hydrogen is because it's attached to a molecule instead of floating around by itself. And that particular sigma bond needs to reach another carbon. It's just that we have these 4 carbons in our cyclobutane, right? So this is a propyl group, even though it kind of looks like, if you look at it this way, it kind of looks like maybe it should be a butyl group, but we do not count this corner piece here in the side chain. We count it in the cyclo. And the way we decide how to number our carbons, and this would be 1 ethyl, 2 methyl, methyl, 3 propyl, cyclobutane. How's that for a mouthful? The way that we determine that is by, I swear to you, it's by alphabetic order. So ethyl starting with E, even though it's 2 carbons, and then methyl for 1 carbon, and then propyl for 3 carbons. I didn't make the rules, but that's what the rule is. So just remember, no matter what the number of side chains are, is you always want to start with the lowest number possible for your carbon. And we know that ethyl is going to be the earliest alphabetic, so that'll be carbon number 1, which is attached to the ethyl group there. So if this was a propyl group here, propyl, and this ethyl's gone, well, now methyl should be carbon number 1 because it's the earliest, so these would be wrong. And you would label this as carbon 1 and then go around like this. And we make it a cycle of progressive numbers whenever we can, but sometimes it's not always possible. Let me give you an example. This is all in the cyclo family, but let's say I have like, well, let's try and make it look clean. So let's get a hexagon out here. Here is, can you guess what it is? Cyclohexane. 6 alkyls in a cycle. Yeah? You get it. Now, in real life, it might not look like that. It might have some weirdness to it like this, right? It's not going to be flat, that's for certain, unless you're looking at graphene or something like that. But there's a lot of ways that carbon can arrange. It doesn't have to be flat. This isn't a two-dimensional universe, but this is a model, right? And it's going to be C6H12 no matter how that's arranged. So we don't really need the 3D version of it for our conversation. Well, what if I put like a methyl group here and a methyl group here? Now they have the same name. And I could label it like this: 1, 2, 3, 4, 5, 6. Or I could label it like this: 1, 2, 3, 4, 5, 6. Now when I'm trying to decide, the question is, when I start from a methyl group as number 1, which direction do I go with my numbers? Well, you always want to choose the lowest. So you would go clockwise in this configuration, and this would be 1, 3. And you would have to move the cyclohexane part over, I guess. I didn't think my positioning through very well. Let's fill that in. 1, 3, methyl cyclohexane. That's the way that you work this problem out. I'm going to try to draw a heptane for you, which is 7. That's pretty close. Let's put a, I don't know, I'm going to need a couple of methyls and an ethyl for this next one. Let's go ahead and try to confuse you. So let's say I put a methyl group here, and an ethyl group here, and a methyl group here. Now we know you got methyl, ethyl, methyl. We know that in the name ethyl is going to come first, but the numbering is not first that way at all. The numbering is going to go this way. I'll show you why in a second here. If I was to come the other way around, and I guess we would label it like this way. Here's 1, 2, 3, 4. You see that these are kind of the same, but look over here. Ethyl can be number 2 if we go around the other direction. So that is the way we actually want to go, because the 2 is less than the 3. I swear this is true. I know it sounds confusing, but you'll get used to it after a couple of tries. So you would call this 2-ethyl and then 1,4 dimethyl cycloheptane. Man, my handwriting's terrible. But the point of this is that when these are in a tie, then who are you looking to over here? Yeah? So notice that the number doesn't prioritize so much in the writing as its alphabetical part. And the numbering is all about staying as low as possible, because this would be 3-ethyl if I went the other way around. Or moreover, if I tried to make ethyl number 1, then this would be 2, 3, 4, 5. This methyl over here would be number 6. Or if I went this way, it would be 2, number 3, 4, 5, 6, and 7. So the methyls would have really high numbers. So the best way to, I lost the E on my heptane there, that was weird. The best way to number this is 1 and counterclockwise this way. That gives us 1, 2, and 4 for our carbon numbers. This is a really strict rule because it really slows down the potential for errors when it comes to both the algorithm your brain uses but also what computers use to understand what you're trying to say. Should we look at another example? Let's make a cyclopentane. It looks a lot like a pentagon, doesn't it? So let's say I have an ethyl group like this and a methyl group like this. So I could do 1, 2, 3, 4, 5, or I could do 1, 2, 3, 4, 5. Either way, we're going to end up with a 1 and a 2 for our side chain. So the question is, who does the tie go to? Well, let's leave the 5 in there. Who does the tie go to? In that case, then you're going to give it to the alphabetical. So that'll act as your tiebreaker. So this is going to be wrong. And you're going to go this way. 1, 2. And this would be 1 ethyl, 2 methyl, cyclopentane. I'm not even going to write that out. Okay, so tie goes to the alphabetical. But now let's take a look at a halogen and see what happens when that's present and not just carbon groups. Let's come back to that cyclobutane, and we'll put a methyl group here. And instead of just carbon, we're going to put a bromine here. We're going to put a halogen here. This is called an alkyl halide. I can write it for you. Alkyl halide halogen. Yeah, ide means single bonded to a halogen. So it's an alkyl halide. It's an alkane, cyclobutyl, right? Okay, you get it. How are we going to label this? Is it the methyl group that gets to go first? No. No, it isn't. It's always going to be the halogen. So it's going to be 1, 2, 3, 4 in this way. And we're going to call it 1 bromo. 1 bromo like that. Then you get 2 methyl. And then your cyclobutane part like that. Do not write it as 1, 2. Always the halogens get priority. So that one should make some general sense. They're usually more rare than all the other carbons, so you're going to end up with the right numbering most of the time that way anyway, but just in case, remember that. Now, what if I look at, let's come back to our cyclohexane. This guy here. Oh, he looks good. What if I have like a bromo here, and I'm going to put a methyl here, and we'll put an ethyl here, like that. That should, in your mind, make sense to go this way. 1, 2, 3, 4, 5. And you get a 1 bromo, and then you would get a 3 ethyl and a 5 methyl cyclohexane. That's what you should find there. I'll leave this to you. What if bromo wasn't the highest in the alphabet like we do for these parts? Like what if it was a chloro? Well, C is still up there, isn't it? How about fluoro? What if this is a fluorine? This would still be a 1 fluoro, 3 ethyl, and all that same stuff, because the alphabet is not relevant when you have a halogen. The halogen is always going to be first. The alphabet is for these carbon groups here, and it's a tiebreaker for that. So it could go 1 fluoro, 3 ethyl, 5 propyl, and then who knows what the butyl should come first, right? If I have a butyl group up here like this, then you would have a 1 fluoro, 2 butyl, and then it would be 3 ethyl group like that. And it just so happens that these numbers are in the same thing. But maybe if my ethyl, let's come back a little bit. This will work out. I'll make this a butyl like this. You would write it as 1 fluoro, and then you would immediately say 3 butyl, then 2 ethyl, and then 5 methyl, and so forth. 5 methyl. Because of the alphabetical order of these groups, once you're only to the alkyl attached groups, this always goes in front. The halide always goes in front. That should be enough confusion to start you off on naming alkanes. This has been a lot of fun, but let's actually put them to use. Let's move on to the next lesson and talk about cis and trans isomerism. To watch this full playlist in order, click on the video here on the left, or to go to the next video, just click on the video here on the right.